start recording. Here we go. So we have this graph over here. It says the graph of the continuous function g, the derivative of the function f. So g is f prime of x. So this is the derivative of f. Shown above, the function is piecewise linear for -5 to 3. So from -5 all the way to 3, those are all lines. And then we have a parabola after that that goes from 3 to 6. If f of 1 is 3, what is the value of f of -5? So f of -5 is equal to, well, let's think about this. If we're given the derivative and we want to go back to the function, we're talking about antiderivative, right? We're talking about integral. Integral is area under the curve, right? Remember, it's area. So really, we're trying to integrate. We're going to integrate from something to -5. I mean, I can't just go, well, I'm going to integrate and -5 is involved. We got to start somewhere. Where are we going to start? At 1. Why 1?
Because we have the value.
We have information about 1, right? So we're going to integrate from 1 to -5, and we're going to integrate g, because if we integrate g, that is integrating f prime of x. I probably could have wrote integrating f prime of x. So we're backing up to the original function. Okay. But if we integrate from 1 to -5, that gives us what we call the displacement. So this area and this area right here is the displacement of the function value. But what are we displacing? What are we adding this to? You kind of got a handle on it. What do you think? To 3, yeah, because that's where we're starting. See, f of 1 is 3, and then if we add on the displacement that we have, in other words, how much should we add to 3? How much should we subtract from 3? But we're going to call it addition. Well, there's the setup. Everyone get the setup or not? Or is that a little confusing? See, we have to have a place to start. We have to have an initial value if we're going to find a function value. Now, if we just want area under the curve, if it says just like letter B, that only asks for the area. That's all it wants. Just find the area. A is a little bit more complicated. All right, anyway, to finish this out, we're going to go 3 plus. Let's integrate from, well, let's find the area from 1 to 0. So we're going to find this area, but we're going backwards. So it's a positive area, but we're integrating from right to left. So that's going to be a negative. We're going to minus that area. So plus, let's call it -1/2 times 1 times 2. So we're actually subtracting it because we're going backwards, like I said. Then we don't get till area again until -1, -1 to -5. Yeah, that's negative area, but we're going backwards. So we're going to add this area on. So plus 1/2, the height is 3, and base 1 is 1, 2, 3, 4. Base 2 is 1, 2, 3. So we have 3 plus, actually, excuse me, 3 minus. We'll just make that a minus now. 3 minus 1 plus 7 times 3 is 21, 21 over 2. So we have 2 plus 21 over 2, that's 4 halves. So it looks like 25 halves is the answer to letter A. Have to have that initial value. If they're asking for values, we need a value to start with on this integral stuff. All right, anyway, the next one just says, hey, what's the area from 1 to 6? So this is going to be, first of all, we have a 2 by 2 here. There's a 2 by 2. That's 4. And then plus the integral from 3 to 6 of 2 times x minus 4 squared dx. So we want this little kind of triangle here and this little kind of triangle kind of shape here, right there. Let's not do that by hand. We got a lot to do, so I want to get moving. Here it is. Well, let's do it. That's from last period or second period. 4 plus math number 9. We're going from 3 to 6. And I need this function right here. 2 times x minus 4, and that's squared, and then that should do it. And I think you saw the answer, maybe. Oh, why do I have z there? That's weird. X. Yeah, it's 10. So the answer here is a little different. That's the displacement right there. So let me ask you this. What is, oh, could we do this? What if they said, what is f of 6? What would that answer be? Yeah, why 13? Yeah, because you'd start here because you know this value, right? You know that f of 1 is 3. That's what you know. That was given to you. And then if we find the area all the way over to here, ends up being 10. So f of 6 is equal to 13. And again, you'd have that starting position, you'd have the area under the curve, the displacement, and you'd add them together. But it didn't ask for that. For -5 to 6, on what open intervals is, if any, is the graph of f both increasing and concave up? Remember, this is the graph of f prime. Let's get rid of that. So where is f increasing? Zero to 6, why? What's positive? You said it's positive. I don't know what it is. G's positive, right? Or f prime's positive. So f must be increasing on 0 to 6. In 0 to 6, where is f concave up? Where is that happening? Zero to 1, 4 to 6. Why? G is increasing. And because it's increasing, the slope of the derivative is positive. But you said it perfectly, absolutely perfectly. Don't use the word slope. Use the fact that the derivative is increasing. All right, so let's answer the question. We're going to go 0 to 1. And I want to include 1. Oh, maybe I don't, because it's not really increasing at 1. So let's go 0 to 1, union with 4 to 6. But there's not a corner or a cusp at 6, so I'm going to include, oh no, open interval. I don't want to include 6. See that? I can be real careful. So I do not include 6. It says don't include it. Y, all right. I'll make the bridge. F prime is equal to G is greater than 0. That's the increasing part. I made the bridge between the graph and talking about F prime. And F prime equal to G is increasing. That means it's concave up, because the second derivative is positive, in other words. Find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. Where are all the points of inflection? What do you think? There is. Is there anywhere else? There's other places that have possibilities, but I gotta let you know if they're actually, it means they're changing, right? Is 0 to a positive 1 changing signs? And it is not. So 0 to a negative, negative to a 0, 0 to a positive, that is not considered changing signs. So the only place where the second derivative changes signs, where the first derivative goes from decreasing to increasing, is 4. That's the only place where we have a point of inflection. So x equals 4, because f prime equal to g changes from decreasing to increasing, which means the second derivative is really changing signs there. So the question was, you know, I mean, is 0 to a positive slope changing signs? It's not. It's not. It means it acquires a sign. Write the equation of the tangent line to f at x equals -5. So I need -5 comma something, and we need the slope at -5. In other words, f prime of -5. And we calculated that, so they want you to go use the answer you got. They do not want you to redo it. Now, if you get a wrong answer on A, that's okay. If you use a wrong answer in a correct way, you'll get the points. So 25 halves. And then we need the slope. Well, this is the slope of f, and it's down here at -3. So -3. Y minus 25 halves is equal to -3 times x plus 5. There's the equation of tangent line. We've answered that 100 times. Just how do you get it? How do you get those values? Any questions on this problem here? Let me stop this and I'll show you, and then you can keep writing it.